We pride ourselves on advanced materials and cutting-edge construction, yet our greatest buildings struggle to last a few hundred years. So how did the Romans build structures like the Pantheon and harbors that are still functioning flawlessly over 2,000 years later? Join us as we expose the timeless and surprisingly simple principles behind their indestructible concrete, lessons that put our modern techniques to shame. An ancient enigma, the Pantheon's dome. Let's start with the crown jewel, the Pantheon. Its dome is the largest unreinforced concrete dome in the world. Engineers today still scratch their heads. No steel reinforcements, no modern machinery. By every logic of construction, it shouldn't still be standing. And yet, it hasn't just survived, it's perfect. So what was their secret? Volcanic secrets, Rome's magic. Ingredients. The Romans used ingredients most builders, today, would laugh at: volcanic ash, lime, and rock fragments. But this wasn't primitive guesswork. When mixed, the ash, pozzolana, triggered a chemical reaction that created a binding force stronger than the cement we rely on today. Imagine building with a recipe that actually grows tougher over centuries. While modern concrete slowly weakens, Roman concrete was designed to fight back. Seawater superpower, concrete that grew stronger with time. And here's where it gets almost unbelievable. Roman concrete didn't crumble in seawater, it thrived. Their harbor walls, piers, and breakwaters are still intact, still resisting waves after 2 millennia. The trick? Seawater wasn't an enemy, it was an ally. The salt water reacted with volcanic ash to create rare minerals, calcium aluminum silicate, hydrates, that actually reinforced the structure. In other words, every crashing wave made Roman concrete stronger. Meanwhile, our modern concrete dissolves under the same conditions, self-healing structures, the cracks that fix themselves. Modern concrete cracks, and those cracks grow until the entire structure fails. But Roman concrete healed itself. Tiny cracks would trigger a chemical reaction, activating unreacted lime particles. Slowly, the gaps would reseal, locking the structure back together. Think about that. A material built to repair its own wounds, centuries before we even dreamed of self-healing technology. Lessons from the past. Engineering for eternity. So what do we learn from this ancient recipe for eternity? First, durability isn't about brute strength. It's about chemistry and design philosophy. Second, sometimes the simplest natural materials outperform our synthetic inventions. Today, scientists worldwide are racing to crack the code of Roman concrete, hoping to replicate its self-healing, water-resistant, and ultra-durable qualities. Because here's the truth. If we want sustainable cities and infrastructure that will stand for generations, we may need to look 2,000 years backward to move forward. The Pantheon shouldn't exist by the laws of modern engineering, but it does. The Romans built not for decades, not for lifetimes, but for eternity. The question is, when will we learn to do the same?